Hello everyone, we are from Team Blade Rangers from NMIMS Mumbai and this is our presentation. During the course of our initial research, we came across several mechanisms for docking as well as for battery swapping that included using magnets, mechanical systems, QR codes, etc. We looked up, reviewed, and understood various companies that have an existing docking mechanism and are in production. Taking inspiration and ideating over a combination of ideas, we eventually had a model visualized in our minds. After iterating over various combinations, we took inspiration from various systems and mechanisms that are there, such as DJI Automated Drone Hanger, EVO Nest Automatic Drone Station, Rapid Battery Hot Swap Station, Sliding Mechanism, clamping mechanism, using magnets, using arms, etc.
Now let us discuss the modifications that we will be making to the existing UAV to achieve VTOL capabilities. We will be mounting 4 motors on the UAV to achieve VTOL capabilities. These motors will be mounted on a single frame. The frame will be attached to the mini talon below its wings. Out of the 4 motors, 2 motors will rotate in clockwise direction and the other 2 motors will rotate in counterclockwise direction such that the motors diagonal to each other will rotate in the same direction. The frame will also have 4 legs that will be used for landing the UAV on the dock. On these legs, we have attached a frame with mounts for the battery. The battery is placed just beneath the aircraft. The battery is placed inside a casing. The mounts for the battery will have tracks. The casing will have rails that will allow the battery to slide through the mounts while swapping and will hold it in place while in flight.
The docking system that we've created is suspended below the aerostat. The concept is similar to that of an hot air balloon. Our docking system consists of 4 funnel-like structures. These funnel-like structures are placed on the surface of the dock as well as go beneath it as well. These funnel-like structures help in landing and securing the aircraft when it lands. We have chosen funnel-like structures because a funnel gives us more room for landing our aircraft. So a much more pinpoint accuracy landing is not that much required. In between the funnels, we have placed a slider which will be used for battery swapping purposes. Once our aircraft has landed, due to the funnel-like structures, it will be able to slide in and be at a pinpoint accurate position wherein the sliders would be able to swap the batteries easily. As a result, this gives us more room and a more accurate system for our landing as well as making sure that our swapping of the batteries is done precisely.
The placement and swapping of batteries in the aircraft is essential component of its operational design. In this setup, the batteries are located beneath the aircraft and the process of replacing them involves a specific swapping mechanism. This mechanism is comprised of a slider that is connected to a docking station. When the swapping process is initiated, the slider comes into action. It is equipped with motors that enable it to move through the docking system. This movement is critical part of the battery replacement process. The slider's motion is activated when the user turns it on or engages its operation. When the objective of the swapping mechanism is to replace the existing or old batteries attached to the drone with a fresh new batteries. The batteries are encased in a protective casing. This casing has a special feature on one side. It is equipped with metal, which is designed for efficient attachment to the slider. The inclusion of rails on the casing of the batteries is an important design feature. The rails will be accompanied with locks. It will facilitate a secure and reliable connection between the batteries and the aircraft's body. The design ensures that the batteries remain firmly attached during the aircraft's operation, preventing any accidental detachment that could lead to malfunction or safety hazards. In summary, the battery replacement beneath the aircraft, along with the swapping mechanism involving a motorized slider and specially designed battery casing with metal attachments, serves to ensure the aircraft's smooth and efficient battery replacement process. This design enhances the reliability and safety of the aircraft's operation, making it easier to maintain and extend its flight capabilities.
Design challenges that we face. The first one is the locking of battery. As we are using sliders, the lock should get open as we are swapping the battery, and the lock should close while we are done. We need to design a proper mechanism for locking of battery. Second is recompute and re-examination of CG. The component should be placed in such a way that the CG should not get affected so we achieve a proper and better stability. Third is a reevaluate an external addition, minimizing the drag and increasing the aerodynamics and efficiency. In this, the frame and the motor that are attached near the wings that disturbs the airflow around the wings of the aircraft. And due to this, there is a disturbance. So, due to the disturbance, the aerodynamics should not get affected, making the slider mechanism more efficient. We're inserting or putting the magnet on the slider such that the battery fits in a slot. Putting battery on the slider will become complex and it cannot be replaced simultaneously. Plan of action. Locking of battery. We are trying to work on a process in which the lock should get open while sliding and the battery in while sliding the battery in and should get closed when it is done. Rechecking all the major parameters like CG, thrust to weight ratio, etc. In this, we will check all the components and its CG on SolidWorks and try to maintain the CG in a proper position. Third is the reducing drag and increasing smooth airflow through aircraft. We will try to put the motor in a proper position and design the frame such that the aerodynamics of the UAV does not get affected, making sure that our system that is swapping, docking, and VTOL more efficient. In this, making we will make sure that the battery is in a proper position on the magnet such that its alignment with the slot it's in proper position and therefore we can do a proper swapping.